Hi all, this is Alan with Bothell STEM Coach, and today we are continuing on with AP Physics 1 free response questions, and we're looking at some circuit problems here. So I have a battery with EMF there, and internal resistance R is connected to a variable resistance R at points X and Y, as shown above. Varying R changes the current and the terminal voltage Vxy. The quantities I and Vxy are measured for several values of R, and the data are plotted in the graph as shown above. Determine the voltage of the battery. Well, the voltage of the battery is the voltage across X and Y when no current is flowing, if that makes sense. Because if there's no current flowing, then the voltage across here is just going to be the voltage of the battery. Because then I would be 0, and this voltage would be the same. This would be the same as Y, and so XY. So I want to extrapolate and see where the voltage is when there's no current. And so from this pattern, I can see that it would be, it's a slope of I go over 2 to the left 2 and up 1, up left 2, up 1. So 4.5 volts. Determine the internal resistance of the battery. Let's see. Varying R. Varying R. I need to know what values of R they're using for the currents here, I think. Oh, I see. Because there is, I see the voltage measurements here. So let me I'm gonna redraw the picture a little bit, so that it's a little easier to understand. So it's this point and this point. This is X, and this is Y, and that's what we vary as R varies here. Okay, and I know that this is 4.5 volts for this battery here. Okay, so for example, when I put it, when it's 1 amp flowing through here, okay, what I know is that I know the voltage across here is 4 volts. So I know that I know it's a 4-volt difference. So if this is say this is 0, I go up 4.5 volts, there's a 4.5 volt difference here, and then I drop 4 volts. I know that this volt is half a volt higher. So I kind of, when I do voltage difference, I like to, you guys haven't done a circuits, you're not really a full circuits electrical engineer, but one of the things I think find convenient is to designate one spot to be ground, to be 0 volts. And so then this is 4.5 volts because the voltage difference between here and here have to be 4.5. And if this has to be a 4 volt difference, that means I have to drop 4 volts. So that means this is 4.5, this is 0.5. And so then I can say, well, if this is 1 amp at 0.5 volts across this resistor, V equals IR, then I know that R is equal to V over I. What's the voltage across this resistance? It's 0.5 volts. What's the current? It's 1 amp. So this is 0.5 ohms. Okay. Determine the value of the resistance R that will produce a current of 3 amps. So if I want, so at 3 amps, I want it to be 3 volts here. So if this is 4.5, I drop 3. Now I'm at 1.5 because this is a 3 volt difference. And I want 3 amps to be flowing here. Well, through this resistor R, I know it's a 3 volt difference between that resistor. So I know, again, by V equals IR, I can find R is equal to V over I. The voltage across the resistance I want it to be 3 volts. And then I'm going to divide by 3 amps. because that's how much current I want to go through. And so that's equal to 1 ohm. Determine the maximum current that the battery can produce. This is a little bit tricky. Let's think of it as a battery and two resistances in series. Okay, so the current is going to be 4.5 volts divided by R plus little r. Okay, and so the power is equal to I times V, and that's equal to this current times the voltage, 4.5 volts. So it's 4.5 times this current, which is 4.5 over R plus little r. Now the little r I can't change. How do I do this without using calculus or without? So the question is what happens as I increase R? Well, determine the value they'll produce. Oh, okay. This will be maximum power when R is 0, right? Because basically, as the smaller R is, the bigger the power is. So I'm just going to do 4.5 squared over little r, because that's when R equals 0. That's 4.5 squared divided by the internal resistance was 0.5. So I do 4.5 squared times 40.5 watts. So that's the maximum power I can dissipate. Because basically, as R gets smaller and smaller and smaller, that's when I'm going to get the most power out of everything. Okay. The current voltage measurements are made with an ammeter and voltmeter. On the diagram below, show a proper circuit for examining these measurements. Use that for the current and use that for the... Oh, okay. So current ammeters always have to be in series with the circuit. And then voltmeters always have to be in parallel. So the voltmeter works by connecting to the two endpoints and measuring the voltage, and the ammeter works by measuring the current flowing through it. Okay. So hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.